Okay. I don't know if you have changed the links though. The last time I tried to stream, it was streaming to the data storytelling instead of data engineering.
It won't stream to data storytelling. It just does that. But when you check later, you see that it's streamed to the right place.
The right place. Because currently I is showing data science track. Okay. So let me admit these guys in. Okay guys, good evening. Welcome to today's live coding session. So can you guys hear me?
Good afternoon, sir. Can you hear me, sir?
Yes, I can hear you. Good evening.
Good evening, sir.
Okay, so welcome to stage C. Today's live coding session. So as usual, four we'll be taking 4 sessions, just as we have been doing for every stage. And for this stage is like an addendum to the previous stage. So in the previous stage, we introduced what Kubernetes is, and then for this stage, we'll be going further to talk about something called Kubeflow. So Kubeflow is a Kubernetes tool that is used to manage and orchestrate computer AI applications. So um, Kubernetes engine generally can be applied to any series of use case, be it a wide series of use case. So be it regular web programming, even Web3 deployment, as long as you need to host something that is not going to be on a local system, Kubernetes, Dockers, and the likes can work. So it has also been applied extensively to the use of AI and machine learning. So if you have gone through the course content, you see that we have a very, very brief introduction to what Kubeflow is. And then in this course, we'll be powering our Kubeflow with something called Micro K8. So just as we have introduced Kubernetes itself, we introduced Kubernetes, we introduced Minikube as a Kubernetes engine, and then there's also something called Micro K8. So Micro K8 is another tool that is used to interact with Kubernetes, just like an engine. So, but you need to have like a Kubernetes engine in place already. So your Micro K8 is like a tool, rather than just like the way you have kubectl to interact with your Kubernetes engine or Kubernetes node or what have you. We also have Micro K8 that we're going to be using for all of this. So today will just be a brief introduction and we'll try to do a bit of setup. So just as I think as we all know, um these things, okay, let me try and bring this old tab here. So in development workflow, there are a lot of changes that is going on spontaneously. So in our course content, for example, we have a method of deploying Kubeflow that uses micro K8. But previously, I think as at last year, the methodology that was on ground was that when you have micro K8, you have something called add-ons. So it's just like when you install Google Chrome on your PC, you use Google Chrome. The major aim of Google Chrome is for browsing, but then you can begin to install things like extensions on your Google Chrome that can give your Google Chrome more functionality. So for example, you can create, for people that know a bit about the Web3 space, use extensions. Your Google Chrome can serve as a wallet for you to store all of your virtual assets. With extensions, your Google Chrome can serve as a way for you to play online games. With extensions, your Google Chrome can give you an assistant that will help you summarize the text of every page. With extensions, you can have like an automatic translator. So those are like the different kind of things. So these kind of things are called add-ons. So you can see these are add-ons that have been added to your Google Chrome. So the methodology we have previously was that with MicroK8 uh you can add Kubeflow as an add-on to MicroK8. So if you see this here, we have this add-on, but yeah, you can see that in the notes they are now saying that the add-on to install Kubeflow is no longer the recommended way to get up. Instead, there is now a complete end-to-end tutorial for deploying Kubeflow on MicroK8. So we'll try and go through this new method of deployment, But that will probably be in the next live coding session, because what we'll be focusing on today is trying to install micro K8 on both Windows and Linux with WSL2. So if you can see here, so all of this I'm showing you are documentations of the official pages of MicroK8. So before we go into there, let's try and see that, okay, what is Kubeflow? So let's see an introduction of what Kubeflow is. So Kubeflow is dedicated to making deployment of machine learning workflows on Kubernetes simple, portable, and scalable. Our goal is not to create blah blah blah. So this is basically what Kubeflow is. So with Kubeflow, we have a whole lot of different machine learning tools. PyTorch and TensorFlow are used for deep learning. Hugging Face is used for deep learning also, but it also offers Jupyter Notebook and Scikit-learn are what we use for traditional machine learning. We have XGBoost. I actually have not interacted with DMLC, but you can see we have a lot of these different tools. So what Kubeflow brings is that Kubeflow tries to give you an environment based on Kubernetes that allows you to use all of your tools in the same environment. So with Kubeflow, you have Kubeflow notebooks, just like the way you'd have used Jupyter notebook on your local system. You have Kubeflow notebooks, you have Kubeflow pipelines, you have the central dashboard. You also have your training operator, your CATIB for model tuning, your KSAV for serving your models. That's making your models available publicly. So that's what Kubeflow offers us. So Kubeflow is like a connector that allows you, it simplifies the process of getting your machine learning workflow up and running for deployment. So because previously, most times for traditional machine learning, it is quite easy to create a Docker. It's quite easy to create a Dockerized version of your traditional machine learning platform and then deploy your traditional, like let's say you're working with a simple random forest model or something. It's quite easy to create these models. But um, when you start moving to deep learning and heavy machine learning workloads, your containers, because of the amount of requirements that you're going to need, your containers become bigger. Let me show you an example of such containers. I think I have a container here that I worked on recently because we were trying to use LangChain and some other models. The container got as large as 7 gigabytes of space. So let me try and exactly. So this is the container here. So is it this one? Yes, I think it's this one. So this is the container. I'm trying to see if I can see the image, the size. Yeah, exactly. So this is the compressed size. The compressed size is 3.28 gig. But actually the size of this is very large. And I think on my local PC, let me try and see if I can showcase it on my local PC. On my local PC, it got as large as 7 gig locally. So it was when we pushed it that it got lesser and is now showing exactly. So this is it on my local PC. Let me just switch my screen. Okay, so new share the window, and then this is the Docker window images. Okay, so this is the image on my local PC. This is it here that is highlighted. You can see the size is 7.3 gig. So this is, and this was just like a very basic version one of this particular machine learning model. So imagine every time you make, because the way it is set up now, um this dockerization is happening locally on my PC, and then after the dockerization, you see me that, okay, sorry, yeah, this is not what I want to show. So after the dockerization, I have to like deploy, push it to Windows Hub again, and then do all of the likes. So something like that, it begins to give some layer of complexity when you have to always keep dockerizing and pushing all of these containers that are very large. The more, and just one more addition to this workflow can make the container even go as large as 10 gigabytes. So imagine having, and every time, because of some of the things that we have done, I think I said this in the last one too, that we have this particular no cache directory where anytime we are redockerizing, we have to always reinstall all of our pipelines, because we don't want to store the models, the requirements files inside. So imagine we're even storing the requirement files, things might get up to like 10 gigabytes. So because of these issues that working with because of these issues that working with machine learning models bring. This is why there has to be like a platform that is already running on Kubernetes itself. So if your platform is already running on Kubernetes, you're already confident that once you are done with your development or whatever pipeline, whatever workflow you're trying to get with your machine learning model, from that particular environment, you can also make it publicly available to users. You can like automatically deploy that machine learning model for it to be accessible. You can deploy it as an API. You can decide to deploy it with a front end version of its own or whatever. But when you are using a Kubernetes enabled environment from the ground up for your machine learning workflows, it makes all of these things easier. So that's what something like Kubeflow offers us. So um Kubeflow is actually very, very complex, and it's something that it takes a while. I mean, it takes a lot of practice for you to get started on. And if you go to the introduction, like getting started of installing Kubeflow, you'll see that they don't actually have like a very, very simplified method of installing Kubeflow. So if you want to use Kubeflow, the recommended method that they use is that they believe that when you want to use Kubeflow on Kubernetes, that you are already on a cloud provider Kubernetes environment already. So you can see that all of these that they have here for the Elastic Kubernetes service, they have the AWS Kubeflow version that you can download using this. If you are on Google Cloud, that's using Google Kubernetes Engine, they have the website. If you are using Microsoft Azure Kubernetes service, you can use this particular website. If you are on IBM Cloud, you can use this. So these are also some other aspects. Or if you are using, so this is the only one that seems like it is as though it is local. So that's VM. So if you are using a virtual machine, a VMware, so VMware, you can install VMware locally on your system, and then with that you can use Kubernetes on VMware and then install Kubeflow on it. So that's the recommended version. So if you want to use, apart from using these recommended versions that are already stable, you can see it here that they have this that um they are intended to be using as the base of package instructions. So they have a warning here that it is a complex system with many components and dependencies. So if you decide that you want to use the raw file, you must be someone that is a bit advanced when you want to do it, because Kubeflow is a bit complex in setting up. And if you want to use Kubeflow, it is no different from the way you would have set up something on the Kubernetes. If I click on this development branch here and I go into this development branch, you will see that what you'll be seeing there is basically what you were seeing in the last live coding session. You'll be seeing pods. So this is the crypto manifest, blah blah blah, apps, official components. So this is where they tell you how you want to install this, the installation, Kubeflow official, blah blah blah. Curiosity site may fail on the first try. This is inherent in how Kubernetes work. So this is just a little different stuff. But if you come here and let's go into, I think, their apps, you will see that they will have a lot of YAML files, and all of these YAML files are just like basically the same thing as what you were using exactly. So config your YAML, so you can see um the workflows, the pipeline, blah blah blah, whatever it is that you want to install. So if you want to install this using the config files, if you go back to this their readme page, you can see that somewhere here it is just like kubectl apply. You can see kubeflow kubectl apply. So this is basically what they expect you to do. So you just keep running kubectl apply for a lot of different for a lot of different files, manifest files that they have introduced. You can see kubectl apply, blah blah blah, a lot of different files that they are provided. So that's why most times it's always, because installing it from the base is a little bit technical, because they expect that you only use this when maybe you want to start something where you don't want any other person to have tampered with the main configuration. So you want to start from the very, very ground up, which is actually a bit technical, and that's why they recommend that, okay, at least you are one cloud provider, and one cloud provider that you want to use, then you install Kubeflow on it. So that's basically a very how Kubeflow is done. So micro K8 let's go to micro K8 and let us show. So you can see micro K8 is the effortless Kubernetes. So it was created by Canonical. These are the guys that created Linux, and then it is the Kubernetes experience for developers, devs, blah blah blah. So um, with micro K8, it's just like you're having a cluster. You know that with Kubernetes, you can have just like I told you, you can have different namespaces, different nodes, just like Minikube is one node. So inside every node, you can have different clusters of Kubernetes. So microcreate offers you one aspect of a way for you to have a cluster in Kubernetes that you can work with. So microcreate was also, just as I showed you when we started this session, so they have a lot of different add-ons that on their own, on the back end, working with their team of developers, they were able to create these add-ons, seeing how stressful it is for people that want to learn locally to work with Kubeflow. You get, there's no all of this that we just read now, it's hard for someone that has minimum resources to try and do all of these things, all of the technical know-how required. So they provided this add-on previously that you can use to install Kubeflow. So it has been updated around 1 year, almost 2 years now, that the add-on is not the recommended way. So in new versions of micro K8, if you try to use the add-on, you might run into errors, and because they no longer support this method, there will be no there will be no solutions to this error. So the only way you can use the Kubernetes add-on on micro K8 is only if you try and get a previous, you install a previous version, like a version that is old. For micro K8, you install an older version so that you can use this older version to try and use the add-on where it was working, at least the last known version where it was working. So that's um what we have. But in this live coding session, we'll try and go through, because I was going through the documentation in preparation for this, and they have this. If you go to their before you start this, so you can see that what they have is that they want you to run Ubuntu on your system, and these are the requirements that they feel that your system should have before you can run before you can use this their new method. Okay, before you can use this their new method of using Kubeflow on micro K8. So they first expect that you have a virtual machine. So uh previously with the add-on, you don't necessarily have to have a virtual machine on the cloud. They have provided all of this. So now they want a virtual machine that runs on Ubuntu, and all of your virtual machine that you have deployed must first have all of this installed on the virtual machine first. Then after you have your virtual machine, then you should now be able to run all of these processes. Your local machine too must also run Ubuntu before you can now start using all of these processes, which is making it quite strenuous than it used to be to use Kubeflow. So I'm still in the process of trying to see if there are other better, simpler methods of using Kubeflow apart from microcase, because microcase used to be one of the easiest, but now with the new method, so now even one has to ensure that he or she has the virtual cloud and everything. But today what we'll just be doing is we'll be installing microcase. So the first thing is we install microcase on Windows. So installing it on Windows is quite simple. I don't even think we'll be doing too much here, because for Windows, Windows has always been about ease and graphical user interaction. So Windows operating system has always ensured that for or even developers themselves, because of the way Windows is structured and the tools that they are provided, it is very, very easy to ensure that you create graphical interfaces for tools that you want people to install. So if you just want to install microcase on Windows, you just download the latest installer, and then if you can see all of these steps, you welcome blah blah blah, click on continue. So you need to determine the minimum parameters. So the way microcase works is that microcase will give you a virtual machine on your system already. So you need to have all of this, you need to have all of this available on your virtual machine before you can before so you need to have all of this available on your local PC, your Windows PC. At least you need two CPUs. So most CPUs, as long as they are using a CPU that is from that was created from 2017 downward, or I think you can even go further back to say like 2014. As long as you're using a computer that was created from then, you should be able to meet all of these requirements, because any computer that is older So if you are using a computer that runs on things like Celeron or dual core, if you are using a dual core, you should be able to run this, but it will lag because most of your CPU will be doing the work for the VM, and then other processes in your system will not have enough resources. So the higher the version of the computer you are using, so you could be using things like Core i5, Core i7. If you are using AMD, you are using like more recent versions of AMD, A4, A7, the A series, Ryzen series, then you should be confident enough to run all of this. So you need to have all of this configured, and then once, as long as you have all of this configured, you just need to click on next. And uh when you are done, you can start using micro K8 on your system, because it will because what will happen is that micro K8 will sorry, the installer has access, because most times when you run this installer, you give them administrator access on your PC. So the installer will have enough access to start changing things on your PC, like adding micro K8 to your parts and all of those Hyper-V. So I think in the last live coding sessions too, we have spoken about something called Hyper-V, and we saw that Hyper-V was you can see that Hyper-V back then, Hyper-V did not have, how would I put it now? Hyper-V was like, it had issues, like it always stopped Docker from working. Like when you are using a Docker environment, the advice is that you should not have Hyper-V enabled. So, but when you want to use micro K8, you need to have your Hyper-V enabled. So for someone like me, where in my system I don't have Hyper-V enabled, before I run this installation process, I have to ensure that I have enabled Hyper-V before I can do this. So that's the process that you have to go through if you are working with, if you want to install it on your system natively. So, but for people that are using WSL2, because just I think I've stated it also, that the standard for cloud development and most things that have to do with deployment of workflow, the standard is Linux, not Windows most times. So even when you are testing locally with when you are testing how do I put it now, even when you are creating, or maybe let me say learning locally using Windows, you always have to ensure that you have it in mind that when you are going to be wanting to deploy, the standard that will have a lot of support anyway is Linux rather than Windows. So you can now configure micro K8, the minimum recommendations are already provided, blah blah blah. Then you can change this, and you can now see, note that there are minimum values. So if you are planning to run large workflows, for you to see how large Kubeflow can be, Kubeflow will require around 12 gigabytes of RAM, and 12 gigabytes of RAM is a lot more than the RAM that come with most systems. Most systems around there should have 8 gigabytes of RAM or thereabouts. So that's why previously micro K8, their previous method used to be like a very very easy way to try and run Kubernetes, because like to try and use Kubeflow, because they have abstracted most of all of this. And then after you have installed micro K8, you can then enable add-ons. So you can see, just like this syntax that we're using to run the enable add-ons here. So micro K8 enable DNS, micro K8 enable storage, enable ingress, blah blah blah. All of these are adds-on to the basic micro K8 system. So just like we had all of these add-ons, that's why previously too we also had an add-on. If um you are going through your course content, you also see that what we have there is micro K8 enable Kubeflow. So if you are done micro K8 enable Kubeflow, then Kubeflow will be activated alongside your micro K8 engine. But then, just as I've stated, they just have a lot of these changes that they have to do, because they want all of this to change. So that's what micro K8 does. So that's a very very short walkthrough of Windows installation. So I don't think the Windows installation will give anyone issues. You just have to ensure, and if you don't know how to enable your Hyper-V, just like they have, I think it was stated here, a switch on. If you don't have Hyper-V, it is possible to use VirtualBox. So you need to have Hyper-V. So if you don't know how to check, let me just show this, how to check if Hyper-V is enabled on your system. So I'll share my entire screen. Okay, and now I will just run this. So once you are using a Windows system, once you show your Windows button, okay, so all you just need, you can just search for something called features. So the once you are searching for features, the first thing you should see is turn Windows features on or off. So I'll open this particular option, turn Windows features on or off. So when it loads on, you see that there will be a particular checkbox called Hyper-V. So you can see this is Hyper-V that I've just enabled on my system. So most time but if you want to run something, things like virtual machines or virtualization, anything that has to do with virtualization, most times you need to have Hyper-V enabled on your system. And you also have containers. So containers is what you need majorly for Docker. And then apart from that, for people that want to use WSL too, you also have to enable WSL. So there's also something called Hyper-V platform. So this enables virtualization software to runs on Windows. So there are a lot of different stuff, but any virtualization, some virtualization platform will use Hyper-V. Some of them will go with Hyper-V. They sound almost the same, but they are two different things. Hyper-V is different from Hyper-V. And there's also the virtual machine platform. So based on whatever virtual machine provider that you want to use, they'll tell you which of these settings you have to enable for you to use your virtual machine. So for micro case, they have specifically told us that what they want to enable is Hyper-V. So if you have Hyper-V enabled, then you are good to go for installation of micro K8 on your system. So now the next walkthrough we're going through is that for WSL2. So because we know that the standard most times is for Linux, and we want to be able to run Linux applications on our system. That's why we have something called WSL2. So with WSL2, you have Linux distros. You can use WSL. It's called Windows Subsystem for Linux. That's the full meaning. You can see it, Windows Subsystem for Linux. That's the workaround that Windows came up with to enable users to be able to use Linux commands on their system, so that when you are working with new tools, you have like a native Linux environment that you can work with, so that when you move from your local system to the deployment environment, you are sure that whatever actions you'll be running are still correct, because you are not working based on Windows OS, you are working for Linux OS from the ground up already. So if you have WSL installed, you also need to have Ubuntu installed on your WSL. So that's how you install. So blah blah blah. To ensure that you have system MD, you also need to enable system MD. So because you can never ever compare the how do I place it now? You can never compare the full package of an application to a bundled package of an application. How do I try and explain this? So it's just like okay, yeah, let me try and explain this. For example, in some countries, we have something called Chinatown, for example. So, but there's no way you can compare Chinatown to being in China actually. So when you're in Chinatown, you see a lot of different features that can, yeah, make you feel as though you're actually in China. But then there will be some innate things that are only available in original China. I mean, China itself as a physical location. So bringing that kind of methodology to this system. So when you have an actual Ubuntu installation on your PC, like what the operating system you are using on your PC is Ubuntu, then you have all of your features available. But with WSL, there will be some things that are just being integrated, because if you say you want to have all of the features that are available on the actual Ubuntu engine on your own system, it's just like having two operating systems. Your system might just crash, or it might lag, or the Windows might not be able to hold all of those processing. So that's why over time there are a lot of different features that keep getting added to WSL to make it look more like to make it look as much as possible as an actual Ubuntu system. So this thing called system MD is like I think the full meaning is system managing directory. Let me just check system MD full meaning. So it's a very system MD meaning exactly. So it is a very exactly, system and service manager. So system MD, system and service manager, blah blah blah. So it is a very important tool for Linux system, because it is with system MD that almost every package that you're installing on your Linux, that is what they used to install themselves on Linux. Um just like on Windows, you have PowerShell and stuff. I can't really say the equivalent on Windows, but system MD is a very, very important tool. So it doesn't come enabled by default on online on WSL, because system MD is like another level of control, a root level access of control that most developers on the peripheral will not require. So if what you just want to be doing with your Ubuntu is to just make use of high level tools, you want to use things like Docker but you want your Docker to be in Linux. You want to use things like Node.js, all of those kind of stuff. You just want to install Python. Those are high level. So you don't need your system MD you don't need system MD enabled to interact with those kind of stuff. So it doesn't come enabled by default. You can run as long as you are working on an higher plane. Most of your actions will perform successfully without an MD. But when you start going deeper to things like Kubernetes, Linux architecture, and all of those kind of things that requires you to make some changes to the Linux main configuration itself, then that's when you need to start interacting with tools like systemmd and the likes. So the first thing you need to do is you need to enable systemmd. So after enabling, so this is the key that you need to enable systemmd on your PC. So you enable systemmd on your PC, and then before your systemmd comes live, you first need to shut down your WSL and start it again. So that will be what we'll be doing. So I'll be installing microk8 on my own WSL tool. So hopefully I'll go through all of the process that we need, and I'll try to see if it is possible that I can install Kubeflow locally, because it takes a lot of resources, and even on my system currently I just have around 20 gigabytes of space free. So I'll probably have to go through some work around to probably create space and the likes. So but yeah, the first thing is to install microkit, and then after you have enabled system MD, then that's basically the major thing you need to do. Then the next thing you need to do is to run this sudo install. So snap, what you need on Ubuntu is snap. So snap is like, even if you go away from here, from WSL, like for this Windows installation, if you go away from Windows, if you go to installing on Linux, I want to just show on Linux. Let me just try install Linux, because I want, so this will be a page not found, install. So this is also saying page not found. Let me see if I can see something install Linux. Let me follow their stuff. Okay, it's still the same thing. So I want to just show you that if you want to install on Linux, even it is also the same thing. So you can see this installing on Linux. So if you want to install on Linux, you just have to do sudo snap. This is the key to install on Linux. So you can see that this Linux here that they have is most likely Ubuntu. Ubuntu is like the default standard for Linux. So you can see what they have here. This command sudo snap install microcreate classic is the same command that you have here. So the only difference between the first 5 commands that you have here is that for this you're already on a Linux enabled system. Meanwhile, for WSL, what you are on is you're on a Windows system. You now need to provide a Linux environment before you can start running all of these Linux commands, basically. So once you ensure that you have all of this, systemmd is enabled and snap should work properly. So if you don't have systemmd enabled, you won't be able to use snap. So that's basically all you need to do, and then with that you can start running of the function. So I will change the screen that I'm sharing now, and then I'll share my full screen, and let us see. Hopefully I should be able to run the full installation process on my PC, even with my limited storage space available. Okay, so if I want to use WSL, there are a lot of different methods you can use on terminal. You can just come here and search for Ubuntu. So Ubuntu is the name of the you can see that this icon here is looking almost the same as this icon here in this canonical. If you come back up, this icon. So the guys that created Ubuntu, the company that is in charge of Ubuntu canonical, they're also the one that created microkit. So they have a lot of support for it. So you can just search for Ubuntu when you have WSL installed, any Linux distro you install will show as an app on its own. You can also look for WSL, and when you have WSL, you click on open. Your WSL 2 should also come on. So you can see that Ubuntu is blah blah blah, secure, strictly configured, mix, blah blah blah. So microkit, just wait. You can see that they are even showing you this their info here about Ubuntu is even some of the other stuff that they have. Okay, so the first thing I'll first do is I'll first show you. I'll run this command here for you to see that systemmd. Okay, so let me run this command here. If I run this, so if I echo this, I think without setting it to true, boot. So this is just okay. No, because I want to see if the WSL config that I have as systemmd as true already, because I think I do have it, but then I want to confirm. So my password, is that the correct one? I see. Incorrect attempts. So what password did I even use? Okay. Yeah, I think that should be it. So I'm typing in different passwords. The reason why you cannot see anything on the screen while I'm typing is that Ubuntu and stuff like this, they want something called for protection sake. So whenever you're typing secrets, things like passwords or sensitive information, it doesn't show on the screen when you're typing them in. So you just see an empty screen, but what you're typing is getting recorded, because so you have to be sure whatever you're typing in, because they do that for security sake. So let me just etc WSL config ls immediate environment snap. So cd slash etc. Okay, ls. So this is my own WSL config. So let me echo wsl.conf or let me say cat. So my own WSL config. So this is the WSL config file. And in my WSL config, I don't have, well, I should be able to. Let me just come here into my Linux. Okay, so this is my Ubuntu, and then this is my etc folder, and then in my etc folder, I have the WSL config here. Okay, so if I go into my WSL config, if I open this, so you can see that my WSL config does not contain any file. So now let me go and enable systemmd. So let me just copy. I'll just copy all of this function here. So what this here is trying to do is when you copy this here, okay, no. So this first part, let me just copy this first part. So yeah. So this first part of the stuff, what this first part does, echo is a command to print out a value. So when you say echo, and then the E means that this is the, you echo this flag of E should mean execution, if I remember correctly. So if you can see that what this is doing is it is just echoing this out, that okay, everything that was passed here is what it is writing out. It first writes something called boot, okay, and then in the boot it has this backward slash and then means new line. So boot in bracket here, then a new line, then enable systemmd to be true. So what this is just going to do is, so when you say echo prints it out on the screen. So if you don't want to do echo, rather than echo, you don't just want to echo this out on the screen, you also want to make this, you want to add these changes to a file. So that's what all of this here is doing. So if I copy this full command here, so what this is doing is instead of just echoing this out, it also wants another command. Or so you take all of this echo execution, the result of this, and pass it into this particular file. So if I run this here, and this has worked successfully, if I go back to this particular file, you can see that it's saying that this file has been modified by another program that wants to reload it. So if I click on yes, the changes that we made, you can see this is the change that we made. Boot system md is equals to true. It has been added to our WSL config file. So this means that we have now enabled system md. So to be able to use it, we need to shut down our WSL. Shut down. So when you shut down your WSL, okay, I see. So yeah, this is the issue. So the reason I can't shut down WSL here is because I'm in the Ubuntu command, not a Windows terminal. So I'll close this now. Let me use CMD for better illustration. So now in WSL now, if I now type WSL, okay, so this is my WSL. So if I do WSL, WSL, and the commands will not be found. So I need to like exit this, exit. So if I do WSL shut down, so this would distro terminated. Okay, Docker desktop, I see. So this is this has caused my Docker desktop to stop, because Docker desktop is working based on WSL. So me running this command of WSL double force and shut down is going to shut down everything about my WSL. So my Docker desktop has been stopped. Everything that is working based on WSL is going to stop because it has to restart. So let's go to our CMD, and this should come successfully. So you can see, so we have successfully shut down WSL. So now if I just type WSL and I press enter, then our WSL should come up again. So it might take some time because of some configuration files and the likes, but we just have to wait for this to come back up. Exactly. So WSL is back up. So now that WSL is back up, now I can use this. So sudo and snap is going to work. So if I do a sudo snap list and paste that here, and I press enter, so I still need to press in my sudo password. So I think, so these are the sudo snap that I have available. So if systemmd is not available, you won't be able to use sudo snap. Basically all of this result is not going to come out. So now I can do I can run this code to install microk8 on my WSL system. So Control C, and now I'm going to paste this here. So this is the classic version. I think there are other versions apart from classic. There's a base version, there's a core version, blah blah blah. But all of these are from canonical. You can see that most of them are from canonical, which is where microk8 was also install. So you can see we have a lot of installation. So this installation might take quite some time. So if the installation does not, but I feel, because I think the bandwidth today is a bit faster, so we should be able to finish this before the ending of the session. But that's basically it. So when we are done with this process, then all we just have to wait is run microk8 status. So once the status is ready, when you have this result that microk8 is running, and that means you have also installed your microk8. So that's basically what we are doing. So let's just wait for this to get installed. But that's majorly everything about installing microk8. So this is the first version of installing microk8. And if you go into your course content, shows you we first introduce what Kubeflow is. After the introduction of what Kubeflow is, we then introduce microk8, and we also tell you to install microk8. But in that process of installing microk8, we also add installation of Kubeflow, which is what might change. So hopefully in our next live coding session, we'll complete the installation of Kubeflow on microk8. So if we are not able to get the previous method to work, then we'll go with the new method that is recommended and try and get that to work. But that will be like another level, because we have to first show how we created our virtual machines using Azure before we then install this, which might not be able to go through everything and then use K8. But let this just okay. So microk8 has been installed successfully, and now And one thing I want you to also understand is that you are saying that they are not using micro K8 alone. So because when you use micro K8 alone, like if I run this command without sudo, if I run this command, it might work. But the issue is that you can see you have insufficient permissions. So because they don't want like a lot of different permission issues, because before you can start using all of these um command line tools that have been made. So what sudo gives you is that sudo gives you administrator access. So as long as you are running a command with sudo, Ubuntu, Linux in general understands that you are running this command with the required access that is required. So that's why when you want sudo for the first time, it asks you for a password. If you don't want sudo for a while, let's say after 10 minutes or 15 minutes, when you want sudo again, to request for a password. So if I come back here now and pick up the whole command, so sudo being there will let the Linux system know that the person that is running this has enough access to run this particular command. So if I press enter now, you can see that what we could see now is the status. So normally what we should just see is an empty response. So that's what wait ready here is doing. So what wait ready does is that it ensures that this command does not end until the micro K8 status is ready. So if we do not have the wait ready, what will happen is that we might have seen an empty response, or just see that micro K8 is not yet ready, and then but what this is doing is that this is going to ensure that our micro K8, this line of code is not going to end until the status of our micro K8 is ready and running. So we're just waiting for this to come up.
While waiting, sir, can I ask a question?
Sorry, can you hear me?
Yes, sir. I said while waiting, can I ask a question, sir?
Yeah, sure.
Okay. Thank you so much, sir, for the lecture. If I understand very well now, a lot of things have been said, but my first question is: you mentioned the need for us to have 2 GB of storage.
Of space, of
Uh,
storage, yeah.
that's for micro plates. Is it only in the cloud or even on the local machine?
That was for the for your local PC, local installation. So on the cloud, most times on cloud you have a lot of space available, because I think the default standard for cloud space is around
Sorry,
256
you
gig.
mentioned RAM, not storage. 32 GB RAM.
Sorry?
Say 32 GB RAM. Because RAM is
No,
what
no,
I
no, no. I did not say 32 GB RAM. Let me just go back to the page to show you what I was talking about. So it is
I thought
in
plenty
this,
space there, 32 GB RAM.
yeah, this aspect of installing micro K8 on a Windows machine. So if you come to Windows, you see that they have it here in their base version. Okay, okay, it was not here. I think it's here. So there was this aspect, install Windows. Okay, let me just use one of these micro K8 slash. So let me just show you what we were trying to talk about. So micro K8 slash install Windows, exactly. So this is it here. So you can see that when they were listing this, so when you want to configure micro K8, the minimum configuration, you can see that the minimum configuration that they have here is 2 gig of 2 CPU, sorry, 4 GB of memory, RAM, and then 50 gig of space on your hard disk. This for a local installation of micro K8 on your Windows PC. If you don't have up to 50 gig of space, I believe it will still install. If you don't have up to 4 GB RAM or space, I think even if you don't have up to this minimum requirement, it will install successfully. The only issue is that when you are running it, it will not be running at optimal capacity. So you can see that they said it here that you can change this configuration later, but if you are planning to run larger workload, so for example, Kubeflow is something that even um Canonical, the creator of MicroK, they consider Kubeflow as a larger workload on their platform, And if you want to run larger workflow like Kubeflow, you will need around 12 GB of RAM. So that's why I was saying that most systems nowadays, the standard they come with is 8 GB of RAM. So if you want 12 GB of RAM, at least you should have a PC that has 16 GB of RAM before you can run Kubeflow. But to run micro K8 on its own, 8 GB or even 4 GB of RAM is enough for you to run Kubeflow on your system. Is that okay?
Yes, sir.
Yeah, sure. So this is still taking some time. So yeah, stuff like this they take a lot of time actually on first installation and first running. So that's why you might have to take some time on your even local PC. So most times when you create, we try and ensure that. That's why even people prefer to run large workflows like Kubeflow on their local on their cloud versions of Kubernetes, because when you have a cloud version, you are sure that your cloud provider will always make it available for use. Unlike local PCs where you can see probably my battery is on 65% now. Imagine my battery was not on 65%, I was on around 2%, and something happens and my PC goes off. It means all of our progress has been lost. And even with WSL, because WSL is like an experimental kind of stuff, WSL has a lot of issues when you hibernate your system. So if you hibernate your system and you want to start WSL, you might start running into some issues like network connections. So depending on how fast your system is, you might run into some issues where, because you can see WSL like a virtual system on its own running on your PC. So if WSL has to port to your local PC network before you can browse. So there have been issues. I faced this with my previous PC also, because when you hibernate your PC, what happens under the hood is that a lot of your configuration files are copied from your hard disk to your RAM. So when you turn back your PC on, your configuration files are now moved from your RAM back to your hard disk. So if the process of copying between your hard disk, if your hard disk is an HDD variant and not an SSD variant, and you are copying those configuration files from your HDD to your RAM, it is slower. And in the process of copying, it might not get copied to the end before your system goes off, because your system cannot keep waiting till all of your configuration files are copied. So on slower systems, the system might even take a while before it hibernates fully, because it is trying to wait for the configuration files to get copied. But it's possible that before your system fully goes into full hibernation, your configuration files are not copied fully. So when you come back up, you might have issues with your WSL. So I always advise people that if it's possible to use Windows for whatever it is you want to do, use Windows, but you just ensure that when you're moving from Windows to whatever environment, and there have now been new support for Windows virtual machines. So if you see, for example, something like Docker Desktop, you can see an option that you can change your Docker from a Linux-based Docker to a Windows-based Docker. So there have now been more support because of these issues that moving from a Windows environment always causes, and when you are going back to a new environment. So this is taking more time than I expected. I did not expect it to take this much time to load. I think probably because, let me even check if it has not used up all of my space, because I have a lot of heavy stuff on my PC, and then I still have 8 gig. As at this morning, when I checked this, I was around at 16 GB free. So around 8 gig have been used just by this installation, and I think some stuff are still going on under the hood that is using more space. So it's probably because my space is a little bit low. That's why it's taking this much time. But that's basically my brief introduction. So today we have gone through introduction of micro K8 on Windows system. On Windows system, it is quite easy. All you just need to download the installer and ensure that you have Hyper-V enabled. Once you have Hyper-V enabled and your installer enabled, then you can install micro K8 on your Windows PC without issue. And also, if you don't want to use Windows, if you are using WSL2, that's what we went through today. So with WSL2, these are the versions. So you just need to ensure that you have WSL updated, you have Ubuntu installed on your WSL. Then you use this command here to ensure that systemmd is enabled on your WSL, and then you just run this particular command which installs it, and then you can wait till you check the status of your micro K8 containers. So that's the a brief introduction to micro kits and installation for different operating systems. So people that use Mac also, If you just go to the documentation page, so if you just go, you can see the URL here, micro kits and the documentation. So everything that most of the stuff we are going to be going through will be embedded in the documentation, and this is how we are going to be moving on for now. So in our next live coding session, um by that time my micro cage should be ready, so we won't have to wait for the status to be ready. And by then, what would happen is I probably would have gone through all of the installation process required to set up the Kubeflow locally. So if it's possible to delete it and then start again while we are live, I'll try that. But if I see that it will take much more time to do it while live, I'll just go through all of the process that I did locally, so you guys can just use the same to set it up on Kubeflow, to set up Kubeflow on the micro cage. Sorry. So with that, we have come to the end of the live coding session. I know it's a lot to take in, especially from people that are coming from programming based, just probably programming in Python or programming in whatever language or writing documentations or stuff. So it's a lot to take in. You just need to be ready to learn. And when you're ready to learn, you also need to be ready to start going through a lot of documentation and start learning new concepts. And you're also going into the part where where you probably need to start investing in more resources, because at this point, low end PCs might not be able to get you to whatever it is that you want to do. All right. So with that, we have come to the end of the live coding session. We'll see each other in the next live coding session. Yeah. Bye, guys. Goodbye for now.